On the page 3 problem set, it tells you to do a couple of investigations, and some of you may have trouble running the manipulatives from the book CD on your computer, so I'm going to run it here and I'll allow you to take the measurements here. Basically, in this investigation 2 on page 351, what we have is a graph showing something falling off of a building, the position as it's going down. So you can see that it takes a few seconds to fall down. The seconds are measured on the x-axis here, 0 to 4 seconds. And as it's falling, it falls 0, 20 meters, 40 meters, 60 meters. And of course, since this is a distance versus time graph, the slope is distance divided by time, which is velocity, right? And we could find average velocity by comparing the y's and x's of two different points and finding the slope. So like for example, point F 2, 20 and point M 4, 80. If we find the slope of this triangle here, that's going to give us 80 minus 20, which is 60, over 4 minus 2, which is 2. 60 divided by 2 is 30. So the slope of this blue line here, the straight blue line between points F and M, is 30. It's 30 meters per second. It's the average velocity between point F and M. Average velocity, you can see, is represented by the straight line between 2 points. But when you want the instantaneous velocity, you actually want a point that is tangent to a point on this parabola, similar to what we did in our first investigation. And we're going to use limits to approach that number. Okay, so let's move down here, and it has instructions on how to do the investigation. But we are going to go ahead and do it. You don't need to read the instructions because I'll tell you what we're going to be doing. So this is the parabola shown in the first graph, and we are measuring the slope between this point F and this point M. And the first thing we're going to do is we're going to take the first triangle they had going from 2, 20 to 4, 80, and we're going to figure out what the slope is there. And the manipulative here figures that out for us. Do you see it already says slope 30, which we calculated by hand before? Okay, so we got that measurement. Now the table is telling us, how about if we change M to t equals 3? What happens then? So we're not going to set F, we're going to set M. So we're going to take M and we're going to move it down to M equals 3. So we got pretty close here. It's 3.007. I'm going to measure the slope now. It's about 25. So I'm going to put 25 here. Okay. And then now I'm going to move it to 2.5. Move M to 2.5. And if I do that, you can see the slope goes down a little bit. It goes down to 22.5. So before it was 25, and now it's 22.5. Now I'm going to take it down to 2.1. So now I got pretty close to 2.1. My slope is now 20.5. So I'm going to write that down. Okay. And last of all, I want to go down to 2.01. 2.01. Oh, I just did a zoom in 10 times because I'm like so small now. To get to 2.01, I really need to zoom it. 2.01, pretty close. Oh, there we go, 2.01 exactly. 20.05. Okay, and so you can see that just moving this chord, the straight line between the blue and the green points, if we move it closer and closer, you see that the slope slightly changes. It started out as 25. As we move them closer, it gets smaller and smaller. But you see the rate at which it gets smaller is slowly decreasing. So you can kind of expect that, it's not going to go to 0, right? So like as you get closer and closer, it's going to approach a certain number. This is a limit. What number do you think it's going to approach? Well, it's probably going to approach like 20, right? If it ends up being a nice round number, when we get to 2, it would kind of approach 20, okay? Now, you can see that, like, if we did get really, really close, we would basically have a triangle that is 0 wide and 0 tall. And once you have 0 wide, 0 tall, you can't take the slope anymore, right? Because the triangle doesn't have any dimensions. So that's why we use limits. We don't actually make a triangle that is 0 wide and 0 tall, because it's impossible to find the ratio of those zeros. But if we find a trend, we make the triangle smaller and smaller. Eventually, we're going to get to the point where we kind of converge to a number. For example, the number 20. Okay. Now we're going to go back and zoom out again. And this time, instead of going from 2 to 4 and making it smaller and smaller and smaller, we're going to do the opposite. We're going to put one of the points at 0 and the other point at 2. So now we're going to come the opposite way. Instead of going from here to here and going closer and closer and closer until we get practically both points on 2, we're going to start with 0 and 2, and then we're going to get smaller and smaller. So let's see. I'm going to put M at 0, and I'm going to put F at 2. So F is going to be at 2, and M is going to be at 0. And I can see that my slope is 9.979. It's about 10, right? So I'm going to put that my slope is 10 there. And then I'm going to move my blue point to the next point, which is 1.5. 1.5. There we go. That's pretty much close to 1.5. And the slope is 17.5. And then, now I'm going to try 1.9. I'm going to put it at 1.9 instead. Okay, get 19.5. Now I'm going to go to 1.99. Let me zoom in a little bit. 1.99. Getting pretty much right on top of it now. I'm going to go to 50 times magnification. Okay, 1.99. And now the slope is 19.95. Okay, what do you think is going to happen if we get to, if we put the blue point right on top of the green point? It's probably going to get to be 20. You see, we kind of came to the same conclusion going from both directions. Let's go back and answer these questions 3, 4, and 6, because I forgot to do that. Observe what happens as M reaches F. For the first one, we saw that the slope was approaching, oh my god, what terrible writing. The slope approaches 20 because as we get closer, the FM gradient converges. It's like the differences are smaller and smaller. And then it asks, for t equals 2 seconds, what do you suspect will be instantaneous speed? Well, it's the slope. Same as the slope, which is 20 meters per second. Okay, and then last of all, number 6, do your results agree with those in 4? Yes, they do. Both converge, both gradients converge to 20. Okay, so that's it for this investigation.